Here, I'm going to start recording here. All right. So today on our starter problem, it's about exponential growth. And the kid wrote this. He didn't have the amount equals, but you know, a lot of people forget that. He had 3,000. And then, actually, that's not in parentheses usually. In fact, I don't think that most of you have this in parentheses. But then the next part, almost everybody puts in parentheses. 1 plus 0.04. Now, could you see a kid putting just 0.4 by accident? That's a really common mistake. 0.04. You got to move decimal 2 spaces over on 4%. See 4%? You move the decimal over 2 spots. Sorry, not there. You go 1 spot over and then another spot over. 0.04. Okay, but the word that I just said, common ratio, that's this part. Okay, so that red part there, the common ratio. And then in 7 years, you put a 7 up there. So when they ask you what's the common ratio, you would say 1 plus 0.04. I wouldn't mark it wrong if you said 1.04. That's the common ratio. Now, if you want to know why the word ratio is even in there, it's because if you took the first two numbers and you divided them in a ratio, they would equal 1.04. All right, so I'm going to show you what I mean by that. The first number is 3,000. Everybody would know that at the very beginning we had 3,000 snails. If I take that and I times it by 1.04, I'm going to get Siri to do it for me. What is 3,000 times 1.04?
It's 3,120.
3,120. All right. If I take that now and I divide them, I get 1.04, but I'd have to put the bigger one on top. 3120 divided by 3000. And it gives me this number, which that's why they call it a ratio. Okay? Just wanted to give you the backstory on why it's called a ratio. You don't have to explain all that in the test. Here's a typical test question that's involving that word. You ready? Write this one down. 6 times parentheses 1.09 end parentheses to the 8th. They could ask you what was the start amount, what was the common ratio, and how much time did it take. So I'll tell you the backstory about it. This is about, remember back in the days of the dinosaur? There were just crazy looking dinosaurs and just crazy looking fish and sea monsters, and there was all kinds of stuff running around on Earth. We know because there's the bones. You can see them, and dug them up out of the dirt. And they had a time where it was really a good place to be a dinosaur here, right here in the United States. And then all of a sudden, it just became a really bad place to be. Do you guys know what probably happened? Scientists don't know for sure. They weren't around back then. But why do you think that all of a sudden the giant lizards were just all like gone? So when did the Mesozoic era, I think it was the Mesozoic, what caused that to end? Well, we don't know for sure. One of the theories is that there was a meteor strike and it hit the Earth, and all of a sudden there was, well, we know there was a meteor strike because we can see this giant, hole in the ground. But we think maybe that caused a whole bunch of volcanoes to erupt, and then that could have clouded the skies, and that could have caused them all to basically die from not just the fumes, but also like plants aren't getting enough oxygen and light and stuff. And okay, so anyway, that would be like decay. But let's say that there was 6 brontosaurus left, and they were kind of having a good year. There's only 6 of them left, but they grew by 9% for 8 years until finally they all died off. Okay, but there was growth for a little while. Then the start would have been the 6. The common ratio would have been the 1.09, and the time would have been the 8. Raise your hand if you would have had those 3 right. Okay. All right. So I am going to give you another word problem like that, and I want you to answer these questions about it. You got to write an equation. You got to tell me the start. You got to tell me the common ratio. And then you got to tell me the answer to the question. So here's the question. You decide to raise alpacas. And you have 36 alpaca. Okay. Turns out you're pretty bad at raising alpacas. You don't know how to, like, actually make them thrive, and so you're losing about 10% a year. After 3 years, you finally give up because you're down to how many alpacas? 36 alpacas, you're losing 10% a year, 3 years later. You got to give me an equation. You got to tell me what the start amount is, the common ratio, and the answer. And when I call your name, just say here while you're working on that problem. I'll pause the video for now. This is probably a good moment for you guys to know that for your next test tomorrow, you can have a note sheet. One piece of paper where you can write on the front and the back side examples for yourself. So like, for instance, let's say you're like, I never remember, like right now I just called on a student, I'll leave the name out, but that didn't know how to write this. If I were you, I would write on a piece of regular paper an example problem just like this. Okay, so you can be like, what was that common ratio again? And oh, it's that part in the parentheses. Oh, I remember. And anyway, do you get how that would be a big advantage? Do you get that you would be so ticked if I said that these 3 kids could have a sheet, but you couldn't? You'd be like, that is so unfair. But some of you guys aren't going to make your own sheet. So my point, I would recommend making one because you would feel like it was totally unfair if I didn't let you have a sheet. So if other kids did get to have a sheet, right? All right, so this is the part where I can't do this for you online kids, but I hope somewhere in your house you have a piece of paper. I am going to give everybody a piece of paper right now, and I'm going to encourage you to write on it something today that you feel like will help you on this upcoming test. Now, if you have your own paper that has lines on it and you want to have that out, fantastic. I don't even have that much scratch paper right now. But if you would rather have some of my scratch paper, I'm going to walk around and hand it out. Okay? So, take notes. Take notes on this particular problem, for example. Write down the equation, write down the start, the common ratio, what was the answer? And then you can go back and learn from that later. Pausing. Okay, so I'm recording again, and here is our equation. Now, I recommended that you write these down on a note sheet for yourself. The starting value was 36. The common ratio is 0.9. I would totally be fine if you had written 1 minus 0.10. Just write whatever's in the parentheses, that's the common ratio. Okay? And last but not least, the answer. Sorkin, what did you get?
I got approximately 26.
So you rounded to 26 alpacas. And that came from this right here being put into a calculator. If you didn't get 26 or a number that would have rounded to 26, you should ask about what you're doing wrong. Sometimes kids forget to put the times in right here. Did you know there had to be a times? Well, on some calculators there does. So if you weren't getting an answer of about 26, you need to put a little star or a multiply between 36 and the parenthesis. I am curious, does anybody's calculator do it without having the parenthesis, or so without having the time sign in there? All right, there's a few of you that where it would work, but I can't promise that everybody's calculator does that. All right, so that's the main meat of what we're doing for this test, other than graphing. So let's spend a bunch of time on graphing now. So here's the other part. Y equals 2 to the x versus, grudge match, y equals 1/2 to the x. Would you make a quick sketch of what these kind of look like? One of them looks like this, one of them looks like that. If you don't know this, well, dang, I'd put it on the paper because you're allowed to have a note sheet. One of them is growth, and one of them is not growth. So we don't call it that. Colin Vatsveen, what are the two names for these types of exponential? Okay, one's called growth, and I bet you can get the other one from that. Decay, good. Now, Sam Bender, which one's which? You are correct. The top one is the growth one. So I'm going to change my pen color to red, and that is what exponential growth looks like. It always goes through that spot right there because that's when it was x equals 0. And if this x equals 0, look at, you're putting the 2 to a 0 power. That's why that spot's there. Okay, and then 1/2 to the x looks a lot like decay. Why? Because you're multiplying whatever it is by 1/2 every time. It is decay, and it makes sense that it's decay. Because you're multiplying something by 1/2, it means you got half as many. So if it was like our moose population in Minnesota, we'd be freaking out. They're only shrinking by like 3%, but if they were shrinking by 50% every year, they'd probably like end up going out and grabbing a bunch of moose and putting them in a place to keep them safe so that they don't like lose the last couple. There are actually some states where they're getting growth in the number of moose, like Michigan. Why the heck are they growing in Michigan and not in Minnesota? There's other situations where there's like islands, like big, huge islands out on Lake Superior, where they're getting growth, but we don't know exactly. All right, so one was growth, one was decay. All right, let's see if you remember what happens when I do this to a problem. 2 to the x minus 4 plus 8. Now, that one's been moved. Pay attention to which way it's been moved. This one's been moved. Actually, the research shows you're going to remember this better if I make you try it first. And if you have to confront yourself with, I don't know, then you will pay attention better. So try it. If you know what this is, write it down. What's that? What's that? It's been moved somewhere. It's called a translation. Don't really like that word. I would have liked them to just use the word shift. All right, Noah, why don't you tell me what you think the 4 was? You are correct. And Luis, yeah, it's up 8. Okay, now there's only one other thing we can do, and that's throw in a negative. And to figure these out, you really best know high vo. If I were you, I'd write this out on my paper, because it's seriously the second most common mistake on this test is you get your lefts and your rights mixed up. Which one is it? Like, oh, I can't remember if this is down or if it's to the right. You get your lefts and your rights mixed up. All right, so what's horizontal? Go with version-y. Yes, and the I that's next to in the high, you know, high vo, it's got an I here. What does that I stand for? Like indigo? Inspiration? Not intercept, nope. It's horizontal on the inside. That's like this. That is the horizontal on the inside part. All right. And in the back, we're going to go with Catherine Ryle. If there's high horizontal inside, what's the counterpart to that?
Vertical outside.
Yep. Vert outside. This vertical on the outside is that. And there's another place you could get a vertical thing, on the front. The very front is also the outside. So I'm going to put one more thing on this. I'm going to put a green negative in front and then say, oh, and it would also have been vertically flipped, also known as a reflect. A negative in the front would have been a vertical on the outside, flip. We are almost done. Stay with me. You're going to have some time to rest your brain in a moment. XY chart. Everybody make one. We need to put some numbers in it. But don't just blindly say, oh, I want to put in 0. Look at what 0 would do. You'd have to go 2 to the negative 4th. That would be a pain. I don't want to put in 0. Like, don't be mean to yourself. Think about what would be easy. What would be something easy to put in this? I don't want 0. I don't want to have to do 2 to the negative 4th. Linus, what would be something smart to put in? 4 would be smart to put in. Everybody put in a 4 into this function and figure out what you get. If you put in x equals 4. Pausing for a second. Yep. So when I put in the 4 for the x, I put it right here. And then I end up with 2 to the 4 minus 4. What's that? Yep. What is 2 to the 0 power? 1. Then what? Plus 8 makes 1 plus 8. 1 plus 8, 9. There we go. So 4 comma 9. Hudson Poole, did you have that one right? Excellent. Would you pick another number that's strategic and it's not 4? 3. 3 works nice. Everybody put in a 3. Lauren Baines, when you put in a 3, up here, you have 2 to the 3 minus 4. What does that mean?
I'm still putting in my calculator.
Okay. I'll come back to you. Sam Bender, 2 to the 3 minus 4. How do you do that? Okay, you guys, I shouldn't have to like call on you multiple times. You're not paying attention. Catherine Yetka, 2 to the 3 minus 4. What do you get? Okay, so here's a new problem. We're going to do this one instead. What was the start amount, Virginie? 2 is correct. Next up, REP, was it growth or decay? Decay is correct. Number 3, Ian Henschel, is the common ratio the 0.07? No. A lot of people put that, but it'd be wrong. It's got a 0.07 in it. So what do you think the answer is? 1 minus 0.07. Good. All right, and the horizontal asymptote. Let's go back to my consistent right answer guy, John Smith. Just kidding. Y equals 5. All right, that's normally y equals 0, but they moved it up 5. That's why the asymptote would be at y equals 5. Now, if you had to graph this thing, I hope you would be able to find 3 points. We're not going to do that for this one. It's just too much of a pain because it's not nice numbers, but you could do it. You'd use a calculator for it. You could find some points on the XY chart. But one thing for sure I know is that this has an asymptote at 5. And another thing for sure I know is that this has been done for 4 years. That's the time. And there's normally an X right there. So if I was going to graph it, I'd want an X and a Y. We wouldn't make you graph it unless they had an X and a Y. All right. So I feel like we're done. I think this is the part where we're going to open up the worksheet. So everybody find the worksheet that's posted for today. and I'm going to ask you to read a problem to me so that I know you're actually on the worksheet. So pull up the worksheet and be ready to read me a problem from the review worksheet. I'm recording right now. Okay, I had a request from a kid about number 4, and it's a very good question. One thing that we had to make sure we knew is whether the negative was inside or outside the parentheses. Do you get that when it's outside the parentheses, then this parenthesis and power would be all done first, and then you'd stick the negative on the answer? All right, next thing, about that negative in the front. Well, it's either a horizontal on inside or a vertical on the outside. If you take away the y equals, it'll be a little more obvious. That negative there, does it feel like it's on the outside or the inside?
Outside.
It's on the outside. So then it's a vertical on the outside. It's a vote. If it's on the outside, it's trying to tell you it's vertical. So if that's a vertical, you'd call it a vertical reflect. So the question on number 4 is to tell you all the things that's happening. So I would say that this one has a vertical reflect. And this 5 up here is a left 5. And last but not least, that is a down. The whole function gets moved down 1. Left is easy. Everybody knows which way left is. Down is easy. Everybody knows which way down is. But a vertical reflect, here's where a normal one looks like. If you're doing a vertical reflect, it's like this way. And so it would be down like that. Do you get how that vertical reflection would work?
So you just graph like the red one?
So yeah, well, if you actually needed to graph this one, I would make points. Now, I don't think they're asking you to do that on this problem, but if on a later problem they ask you graph this, you just make points. Because like I've said before, if once you make the points, that's the hard part. All you got to do is graph those points. And so if you wanted to kind of know what it looked like, it would look like this red one, except it would be moved also, the things that I said before, down 1 and left 5. So if I took this red one here, after flipping it, and I also moved it down 1 and left 5, it might look something like that because it's been moved down and to the left. That make sense? Okay. But if you ever don't want to know for sure exactly where this thing is, find some points. -5 would be a very strategic, smart thing to stick in because it makes the power 0, and that'll work out really nice. Okay, so again, number 4, I don't think they make you graph it, but they make you say that it's a vertical reflect. And it was vertical because it was on the outside. All right, that was a very good question about number 4. Do you have any other questions about this worksheet? Yes?
I don't know. It's the same exact problem.
Okay.
But it's asking how would you change the parent functions?
All right. So here's the parent function like points. So the original parent function would have been y equals 3 to the x. So if I gave you these points for it, like I stick in x and y, I stick in 0, I get 1. I stick in 1, I get 3. I stick in 2, I get 9. I hope you guys know how to do those. You just stick these numbers here into the equation, right? But then if we do this, how do we actually do left 5? What do we do to these points here to move them to the left 5? Do I mess with their x values to go left or their y values to go left? Hint, this is left, right. The x's are your left, right things. And your y's are your up, down things. Okay. Good question. I'll pause again just in case there's other questions. Okay, so I did get this question a lot from kids about the question that says, what would you do to the table? I didn't teach you guys that way, and so I'm not worried about that question about what do you do to the table. You just have to be able to graph them, which means you just have to be able to use your XY chart. So problem 5, don't stress about problem 5 on the worksheet. You just on that one, I would say you would take the y values anytime you're doing up or down, and you would change the x values anytime you're going left or right. That'd be a good enough answer for number 5. Okay, that's all I got for the video for today.